All right, here we're going to walk through our notebook and the notes that you need to be taking for section 6.2. This is a fairly simple section, so all that you need is your math notebook and some colors. So again, it really helps to take notes in colors so your brain can remember that too. So I use just different colored pens. You could use colored pencils, you could use some markers, whatever works for you, but you will need some sort of colors to differentiate. Okay, so we're going to start on the next page in your notebook, right? And here we're looking at section 6.2. And in this section, we're really going to be learning about radicals and rational exponents. So you want to give yourself that note so when you look back at your notes, you know exactly what you're looking at. Okay, and so we always want to start with our learning targets. The first thing we're going to be doing is finding nth roots. And I'll explain in just a minute what that nth stands for and what it really means. So we're first going to be finding those nth roots. Then we're going to evaluate expressions that have rational exponents. So let's just take a second and think about what rational actually means, okay? So what does rational mean? Well, rational means that the number can be written as a fraction, okay? So can be written as a fraction. I'm just going to abbreviate it as that. So it can be written as something as a over b, okay? So we're dealing with fractional exponents here most likely, okay? So then our third learning target is we're going to do some solving, some real life problems. Okay, using those rational exponents. So these are our three main learning targets. So first we're going to look at nth roots and what they mean, and then we're going to be evaluating some expressions with those exponents, and then we're going to look at some real life problems. So this third learning target, these real life problems, really are going to be what you're doing when you're working on your homework and the practice problems for you. Okay, so here's one thing we need to know. Okay, so we're starting off with these nth roots, and I'm going to go ahead and use blue for this one. So if b to the n equals a. So if I have a base, that's what this b stands for, and I take it to an exponent, right? That's that n, and it equals a. Then I know b is an nth root of a. Okay? So this is what we're going to kind of live in. We're going to kind of live in our exponential land, okay? And we'll keep going there. So I have a base, taking that to an exponent equals a. So I know that then b is an nth root of a. So let's look at what some real nth roots look like. Okay, and we're only going to be talking about real roots here. So the real nth roots of a. Okay, there are some rules that we just want to follow just to kind of keep things simple. So I know that n is going to be an integer, right? That's greater than 1. Okay, so that's the important part. So n is always going to be greater than 1 here. And so then a is also going to be a real number. We're not going to deal with any imaginary numbers right now. Okay, so if keeping these two things in mind, if I know that n is odd, right, so if that is an odd value, then I know that a has one real nth root. Okay, and what that looks like is the nth root of a equals a to the 1 over n. And we're going to look at some numerical examples of this, some numbers, but this is just kind of what we want to keep in mind when we're going through those examples and working on our homework. Okay, so I know if n is odd, I've only got one real root. If I have n being even, but a is greater than 0, right, because a is a real number, so it could be less than 0, but if a is greater than 0, so it's a positive value, then a has 2 real roots. So what that looks like is I still have that nth root of a, but it's going to be plus or minus a to the 1 over n, right? So if it's even and a is greater than 0, I have to have this plus minus in front of here. And this will make a lot more sense when we start getting the numbers, but just keep in mind, if it's even, if n is even and a is greater than 0, I have to have that plus minus. Okay, so now we're going to see if what if n is even and a is equal to 0. Well, if a is equal to 0, then a really only has one real root. And that would be, in fact, the nth root of 0 is 0, right? Because it doesn't matter how many times I multiply 0 times itself, I'm always going to get 0. So that's what that's telling me. Okay, so then our final thing is if n is even and a is less than 0, then I have 0 real roots. So let's look at what that would look like. So if a is less than 0, that means that the thing that's underneath my radical is negative. And right now, we don't know how to deal with that or what that is, and it's not a real number. It's what we call an imaginary number. So right now, all we need to know is that if that a value is less than 0, then I have no real roots. Okay? So this will come up in your homework sum. Okay, so the next thing we're really going to be looking at is those rational exponents. All right, we said that a rational exponent is really that fraction. So here's kind of just how we want to keep these things in mind and remember them. So I know that if I've got a, which is in this case my base, and here's my exponent, m over n, that's the same thing, or it equals a to the 1 over n times to the nth, right? And this follows some of our rules of exponents. So I've just kind of split that up. That also equals the nth root of a to the m. Okay, so I can always remember this. So my big example, how I always want to remember this, is it always helps me to write a number down. So I know if I've got 2 to the 1/3, that equals, the denominator becomes the root that I'm taking of 2, and my numerator comes inside with that value. Okay, so now here I'd be finding the cube root of 2. So I can go back and forth between these two different ways to write it, depending on which thing I'm looking for and what really is going to help me. Okay, so now we're going to actually look at evaluating those nth roots. Okay. So we're going to be evaluating some of these nth roots. So here's where some colors are really going to come into play. Because we talked about a cube root, but what does that cube root actually really mean? So here I've got the cube root of, and I'm going to go ahead and use my light blue, a -8. Okay? So what this is actually asking me, and this is where people really tend to struggle, the question this asks is, what can I multiply by itself? That itself is the very important part. 3 times, right? That's where that 3 comes into play to get that -8 value. So what can I multiply this number of times by itself to get this value that's on the inside? That's really what we're looking at with these nth roots. So for this example, I would know that -2 times -2 times -2 gets me 8, and there's 3 of those. So I could rewrite it as the cube root of -2, -2, -2. And it's really important here to notice that I have this 3, this cube root, so that means I need to have 3 of these. So that tells me that my final answer would be -2. Okay, so let's look at another little example here. So if I've got 16 to the 1/4, this also tells me, right, remember from our last page, that the denominator tells me what value goes out here. So the 4th root of 16 tells me what can I multiply by itself 4 times to get to 16. So I'm still looking at the 4th root of 2 times 2 times 2 times 2. Because I know 2 times 2 is 4, times 2 is 8, times 2 is 16. So my final answer here would be 2. Okay, so one more little example that we're going to look at here. So I've got 27 to the 4/3. So let's rewrite that in radical form, right? So the denominator becomes the root that we're looking at of 27 to the 4th. Okay, this can also be the cube root of 27 right there, then raised to the 4th. So this tells me, this 3, remember, what can I multiply by itself 3 times to get this 27? So I know that I would have the cube root of 3 times 3 times 3, right? Because 3 times 3 is 9, times 3 is 27. and I can't forget to the fourth. So this would then equal 3 to the fourth, which would then equal 81. So this is how we can use these properties and these rules to actually evaluate and simplify as far as we can. Okay, so now this is actually all the notes that we're taking for this section. So now that you have kind of the basics and your reference guide, now I want you to take these notes and use them to help you figure out the different homework problems that you're going to be working on. And don't forget that third learning target was those real life problems. Those are the word problems that you're going to be dealing with, taking this information and applying it. So go ahead and open up your homework and start working on those problems.